I have trust issues with the AUR. When I bring this up, a lot of people will get a little bit defensive, which I can understand because the AUR or the Arch user repository is one of the biggest factor for a lot of people to choose Arch Linux or an Arch-based distribution when they choose what Linux distribution they want to use, because let's face it, the AUR is great. It makes it possible for you to install a wide variety of software on your Arch-based system. But even if you check out the Arch user repositories page on the Arch Wiki, it will have this big red warning here, which will tell you that the AUR packages are user-produced content. These are completely unofficial things. They have not been vetted, and you should only use them at your own risk. So, if I have trust issues with the AUR, that's seemingly justified by the Arch Wiki page. And in today's video, I would like to elaborate on what these kind of trust issues are, and in general, why do we have trust issues with software. We are going to be talking about distributing software for different platforms, but mostly for Linux, of course. We are going to be talking about getting software directly from the developers. What are these official distribution repositories that most Linux distributions have? Some of them, they don't have their own, they use someone else's, but we will get into that. And what about the shady install scripts from the internet, and how do they relate to the Arch user repository? So in general, when we are talking about trust in software, and let's just talk about free software at this time, because if we are going to be talking about proprietary software, and that's going to be another can of worms with regards to trust. So in free software, basically what is generally defined as free software is whatever gives you the four computing freedoms, four fundamental freedoms of computer or computing, I guess. And one of them is that you have the freedom to investigate how the software works and change it to fit your purpose. And generally, a lot of computer users are out there who are not programmers themselves. They don't really know how to understand code. And even if you understand code, you don't have the time to understand everything that is running on your computer. So how could you verify if that software is really doing whatever you're doing or whatever it tells you it's doing? And well, basically, we just trust in the wisdom of the crowds. In this case, I guess for free software, that if there is something fundamentally wrong with the software, people will figure out. But in general, that is a question that you have to ask yourself, whether you can trust the developer of certain software or not. And if we are talking about the distribution of software or installing software for different platforms, one of these possible options is just getting every software that you need, just install on your computer by yourself. So you will install the kernel, the user space utilities, all the libraries you need, the Office suite, the video editor, web browser, everything. You will just get the source code maybe from the developers and build them on your own PC, and that's where you put your trust is. You put your trust in the individual developers. And of course, in case of like a platform like Windows, this is generally what people, I guess, got used to, is that they go to the internet, go find the website of the developer of the software they want to install. They get an installer and install it, and just hope that both the installer and the software does what they hope to do. But of course, in Linux, we have also the possibility to build our own binaries from the source code that we download. But it's still a lot of different stuff we need to put our trust in, and it's even, in Linux more complicated than on Windows, for example, because Windows will just give you this huge black box which contains the kernel, the graphical user interface, the file manager, even a web browser, just in one package. But in Linux, where we are working with free software, everything is developed by someone else, basically, and we would have very difficult time if we wanted to check everything, whether it is malicious code or not, so we can avoid this malicious code sneaking on to our computer. And this is basically what the centralized package repositories are trying to solve. This is kind of similar for commercial operating systems like Android or I guess a lot of Android versions, and also the iOS, for example, that they also have like a centralized repository. In that case, they have an app store, and so you get your software from a centralized place. And this would mean, in this case, for example, in the OpenSUSE case, that the maintainers of this distribution repository will basically what they will do is they will just look through the internet. So our Linux distribution needs the Linux kernel, so we will get the Linux kernel, compile it, and then distribute it to our users. We will get the GNU core utils, compile them, distribute, etc. We will choose what kind of video editors, what kind of web browsers we want to offer to our users. Then we are kind of making sure that whatever we are choosing to offer through our repositories that does not contain this malicious code. There is no secret crypto miners in there, things like that. And so in this case, because they are making these very conscious choices of what to include in their repositories, you can either decide that you trust these choices, or you can decide you do not trust these choices, and based on that, you can use the distribution, for example. So in Arch Linux, there are these three main repositories, the core and the extra and community, which are maintained by different groups. But in general, if you kind of trust Arch Linux as a system, and this is where you get your software from, you only need to trust them that they will make the right choices. You don't have to trust any of these developers separately. And of course, in a modern Linux system, you might install some of your software from these official repositories, but some of them you install from somewhere else. So maybe in case of the Snapstore, you will have some of your programs from the Snapstore, but you have to make sure that you can actually trust both your main repository, so main distribution repository, and you can also trust the Snapstore. In this case, we know it's run by Canonical, so if you are using Ubuntu, then you might kind of argue that, well, it's same difference, but we have to make into consideration, I don't know if you saw this to turn to gray here, these arrows, but what I try to symbolize here is that in some cases, and I'm not sure, but I think the Snapstore works like this, so the Snapstore itself, they don't go around and proactively choose what they want to include in the Snapstore. They just have some kind of a software that makes it easy for any developer to create a snap package. So there is no proactivity here. So anyone can put their package into the Snapstore, and maybe there is some reactivity. So if it turns out that someone packaged something that does not belong in the Snapstore, they can remove it later, but you can still kind of have this issue when you install it before it got, kicked out from the store. So you have to kind of trust that they kick malicious code out of their store with efficiency. And that's where we get to the AUR, how the AUR works. And so everyone knows that if you don't find a software in your repository, you cannot find it in a third-party repository. Maybe there isn't even a PPA. So Ubuntu has these third-party repositories that you can add to your main repositories, but those are also kind of maintained by the same people who write the software, so they don't give you an additional layer of security in that sense. So there is no centralized repository. There is no someone who takes up all the jobs, takes up the job to kind of figure out if this software should be used or not. This is just the software author itself makes a PPA. You can install it from there, or even if that's not possible, you might just go the shady install script I found on the internet route, which usually looks like you download like a text file, which is a script. You add that text file, the executable privilege, and then you just run the file and hope that it actually installs the software on your computer that it purports to install. And in some sense, the AUR is not that different from that, because in that case, you might get this install script from the person who wrote the original software, so you just trust the developer that the install script. So if you already trust the developer that they wrote the software properly, it's not a big stretch to also trust that they wrote the install script properly. But in some case, maybe the install script was written by someone else and you just found that in a very separate website. And in the AUR, basically the AUR, what is the AUR is a collection of these kind of random install script, because the Arch user repository is not a package repository. So it does not contain packages that you can directly install. So on Arch Linux, of course, you install packages with pacman. The AUR does not contain, it's not a repository of packages that you can install with pacman. The AUR is a repository of package builds, and the package builds are basically scripts which contain a lot of standardized variables and standardized functions that the make package utility can use to download different software. And one of the things is they have this source array which will contain web address. It's generally like a GitHub or GitLab repository, or maybe a tar file, like a kind of a compressed collection of source code, maybe from SourceForge, but it can be literally anything. So this will be downloading something from somewhere on the internet, and it will have like a build function in this script, which is kind of the random install script from the internet type of thing that will do something to build the software. And then basically what it will do is this script will build the binary. If it needs to build a binary, basically make all the components of the software in your home directory. It will package it up and then use pacman to install this homemade package, and that will install the software system-wide for you. And basically, in this case, of course, because this is the AUR Arch user repository, this is only for Arch Linux, a lot of the cases is that the author of this software that you are trying to install did not write the package build script. The package build script was written by someone else. And then it comes to question that while we can come to a conclusion whether we can trust this developer or not, we also have to kind of trust who wrote the package build. Or, of course, you always have the chance to check the package build itself. These are, of course, much more easy to understand what this package build is doing than reading the source code of a full-blown application. But still, package build scripts can get kind of complicated and become more complicated than my pay grade, especially when it's building some graphical application over there. And if you are not familiar with the build processes, then you kind of have to just, take it on faith, or faith rather, take it on faith that this package build was written properly. But of course, you also can trust how well this repository is curated. So maybe you just ignore whatever is in the package build and just put all your trust in the fact that this is the AUR, and people can leave comments on this package build. So maybe if this was doing something really shady, someone would have already figured out and reported it. So this is what I mean by having trust issues with the AUR, that you have to decide. So while generally a regular package repository for a distribution that is curated will reduce the number of parties that you have to trust by basically you just have to trust that the repository maintainers of your distribution do their job well, and you can ignore all the issues with the software developers, because you just trust that whatever is going into your repository, you can trust from your repository maintainers. But in case of the AUR, there is not anyone who would take on the responsibility of curating anything. It's basically you have to trust +1 compared to just the author of the software itself. So it does not mean, of course, that you should not use the AUR. I use the AUR personally for a few software that I couldn't find anywhere else. but I think it is a good idea to be aware of these issues and not just blindly, acting or pretending like installing things from the AUR is the same as installing it from the main repositories. And this is why I personally would never use Yay or any other AUR helper that kind of mix installing things from the main repositories and from the AUR together. And this is why I would not really like to use, I think Garuda uses that method, that they just have like a server somewhere which just randomly, or I guess it's not randomly, it goes through the whole AUR and builds every package from the AUR, so it will act as a repository, because in that case, those binaries, in that case, you don't have to just trust that the package build is written correctly and also the developer wrote the software correctly. In that case, whoever is building those binaries on their third party, or I guess it's like 1, 2, 3, 4, fifth party server, you also have to trust that when they build those binaries, they don't sneak in anything sneaky in there. But I guess this is the end of the video. Now we know all about trust with software. If you have any questions, comments, you can leave them down below. You can always follow me, of course, and especially don't follow me, follow my work on the internet. You can find all my socials around and my GitHub, and you can give me money on Patreon if you really want to. And I will see you in the next video. Bye bye.